Welcome, folks, to this fireside chat. We're going to talk about cloud computing and edge computing, and how to get started. What does it even mean to all of us, right? But before we do, let me just quickly get us all introduced. First of all, this fireside chat is done in conglomeration of NASSCOM, Simplilearn, and Bernard himself. All three of us working together. So if you came through NASSCOM, a special welcome to you as well. And let me quickly introduce our panelist, the main person here today, Bernard. Bernard, actually, you should probably introduce yourself. You're a veteran of cloud. You know everything that's going on in the industry and highly valued opinions that you share. So I'll just pass it back to you.
All right, Anand. Thank you so much. Well, yes, as you mentioned, I've been working in cloud a long time. I've got started with it. I was writing a book, Virtualization for Dummies, and I was going to put a chapter in there called The Future of Virtualization. Where's it going? And I was sort of stuck, like, well, where's it going to go? And I went to a meetup, and it was in a community center down in Palo Alto, kind of an old school that was kind of beat up and not very elegant and kind of run down. And the speaker that night was a guy from Amazon, and it was an enterprise architecture meetup. So I said, why is a guy from Amazon here talking about enterprise architecture? And he stood up and he said, I want to tell you about this service we just launched called Amazon Web Services. And by the end of that lecture, I went, that's not just the future of virtualization, that's the future of IT. And really threw myself into it from then on, and I've been working at it for just about a decade now. And I would say that my intuition has been borne out, but I would also say that my belief is that if I can use a baseball metaphor, we're in the second inning. I don't know what the right cricket metaphor would be. We're in the first overs or something like second overs. We're still early days in what's going to go on with cloud computing.
Mini introduction from my side. I'm the Chief Product Officer for Simplilearn. It turns out, and I've left this world behind, I actually ran the product management division for a cloud computing company called Rackspace a few years back. And while I still stay in touch with cloud, Bernard is the expert here. I'm only going to try to see if we can get the best of his thoughts around this topic. Before we get started, some quick housekeeping things. I do want to make this interactive at the same time with all the attendees we have here. It's going to be impossible to have a lot of questions come in orthogonally and all over the place. So please put your questions in the Q&A section. I will be skimming those, making sure that questions are answered as they come to us and as they are on point. If they're not on point, I'm going to keep them to the end, and I'm going to ask those questions to Bernard at the very end, okay? So keep your questions coming. I'll be looking at those and making sure that we cover those. So Bernard, ready to get started?
I'm ready if you're ready.
All right, let's do this. So, let's start with the very simple basic things, right? Because edge computing, it's a pretty relatively new term. So let's start with actually de-obfuscating, just explaining what edge computing is. How does it differ from cloud computing? Why don't we get started with something pretty basic?
Sure. Well, the notion of edge computing is that, in contrast to cloud computing, so cloud computing is basically computing at the end of a wire. It's a big centralized computing environment, like an Amazon Web Services, like a Microsoft Azure, like a Google cloud environment, and or cloud engine, computing engine. Sorry, it's a little early in the morning for me still. Anyway, they're all centralized. The notion with edge computing is that you would migrate some amount of computing out to a place where something is going on. And some people sort of go, well, we've had that before. We called it PCs, or we called it, whatever you might call it. But this is a little bit different in that I think it's a little different. Most people mean something different in that it's not a generalized computing capability like a computer is. It's more of a specialized device typically, or it's computing associated with some kind of a device that is appropriately smart. So kind of an example might be you've got some sort of machine tool running, and you want to make sure it stays within tolerance, and if some failure condition happens, you want to be able to respond to it immediately and shut it down. Well, you could have some amount of computing on that device, and it would be reading these metrics, and if it got to a warning level at one of those metrics, it would issue a shutdown. So that computing is out at the edge. It's located on the device as opposed to being back in a centralized data center. So conceptually, that's the sort of thing that edge computing is. It's computing being attached to or integrated with some sort of device, and that device can be made more effective, more efficient, whatever it might be, by having that computing attached to it.
Gotcha. But, someone might ask, right, then two questions really quick. Isn't cloud supposed to solve all those kind of decisions anyway? So why do we need this edge device? That's question number one. And actually, I'll hold off question two after that. Let's start with that. So why do we need a device that's sitting on the edge of the network? And why wouldn't you just actually have all this computational power and everything just sit on the cloud itself?
Well, at least from my perspective, there's a couple of reasons why you might want to do that. And one is in situations or for devices in which the latency that you would have from communicating from that device across a network back to the centralized computing power, and then some information or some command being sent back across that wire. There's some latency because it's a round trip. So that's one reason. The second is if there really is no connectivity. So, think of a remote aid, a foreign aid kind of situation. They're working in a remote location in a country. There is no wire they can connect to that will give them computing back to a centralized location. So they need, local computing. Although, to a certain extent, that just means you've got a little mini data center at that remote location. So to me, that's sort of, you can call it edge, but it's, I think of edge as being sort of specialized devices. That's the way I think about it, as being something worthy of a different term.
Gotcha. And
specialized term.
Yeah, it makes a lot of sense. So basically what you're saying, just to make sure the audience got the summary right, in some sense you want to make certain decisions at the edge where you don't want the latency of the network that goes all the way to the cloud or the data center at the place where the decision gets made. So you're shortening that time, you're making decisions quicker, you just get better outcomes in that sense, right? But some people might ask, how is this sort of a subset of IoT, which is another big buzzword out there, right? Are these just devices that are talking to each other, and what's the difference here? Do IoT devices, is IoT a bigger thing? Is edge computing part of that, or is it completely separate there?
No, I think it's really sort of it's the same thing with a different name on it. It's Internet of Things, and devices are things. They're sort of, IoT sounds pretty cool, so you say IoT. Edge computing sounds, well, it's okay. And again, it's devices or machines or whatever you want to call it that can operate more efficiently or more effectively by having computing attached to them. Can I offer an example?
Please, we were going to get there, so this is perfect timing.
Yeah, well, so I talked to Microsoft, and they've got an offering. It's kind of a package IoT offering. And AWS has one as well. I'm sure Google is developing one. I don't think they have one right now. But so they worked with a manufacturer that took this Azure computing, and it's basically the Azure interface. So from a perspective of programming it, you still got the same APIs. It's just the computing is located onto the device. And this device was a machine tool. And again, at certain fault conditions, it wanted to be shut down immediately. Because if it ran even a little bit, like a second, it could run into, a failure condition that could be damage to the tool. Obviously, you don't want to have that happen. So the Azure IoT was used to place some computing power onto that device. Now, interestingly, this was a, I don't know what you would call a hybrid situation or a distributed computing thing, in that most of the computing that was done around this device was actually done in the main Azure cloud. There was a subset of the overall computing that was done on the device, and that was placed onto a device. And it was interesting. It was like a Raspberry Pi level computing power put onto the device. So it would capture certain signals. And, oh, that's a signal there's some danger. I'm going to issue a shutdown. All the other kind of content data would go back to Azure. And the difference was the Raspberry Pi scale device that was sitting on the thing could respond within milliseconds, maybe even microseconds. Whereas to go back to the centralized computing and back and do the whole round trip and all the computing inside and all that was 2 seconds. And, there are certain kinds of situations that 2 seconds is too long. So, so they split up the computing. So that's an example of what this edge computing can be like.
Brilliant. By the way, just a quick tangent for audience. There's an interesting question that's come up. Please hold that question. I'm going to get to that. The question basically was, how do I get started? What are the skill sets I need? There's actually a section we're going to cover in a few minutes of, tools, capabilities, things like at the very end. So kindly hold that question. I've captured it. We will get to it for sure, right? All right, so continuing on use cases really quick, right? Some people might say that edge computing is basically, decentralizing what used to be centralized in a cloud data center, right? So are we back to a situation where, the cloud's getting decentralized and the cloud's basically disappearing and everything is going to be done with edge devices? Or do you think these two coexist in some form or fashion?
Yeah, I think they're likely to coexist. I've heard people voice, well, this is just part of the ebb and flow, the tide coming in, the tide going out of centralized versus decentralized computing. But in the past, that was really made up of sort of general purpose computing being spread out to, to remote locations or not centralized locations. The PC is a perfect example. PC was a general purpose computer. You put it on your desk. You could run a spreadsheet. You could run a game. You could run some kind of analytics, whatever, word processor, whatever it might be. What we're talking about here is not a generalized computing capability being put somewhere. It's specialized. Like that machine tool, it was reading signals that were specialized to that machine tool and responding to them. So it wasn't like somebody's going to say, well, one person could say, well, I'm going to do this machine tool thing, and another person would say, I'm going to write my novel on it. No, it was a specialized, and the point about it being a Raspberry Pi device is it was a super cheap device because it was special purpose. It only did one thing, and it even did a subset of that. It just caught a few signals out of this machine. So you want something that's $5 or $10. The economics wouldn't afford if you said, well, I'm going to attach a PC to this machine tool. So at least in my view, which may be a little bit controversial, is that this is likely to be specialized devices out at the edge and not a generalized spread of computing.
So perfect. You said specialized. When I think of specialized devices, I always think of very specific use cases that these devices are trying to solve, right? In your experience and your exposure to these kind of devices, can you maybe give the audience a sense of applications where this might be interesting? Because a lot of people actually try to architect their architecture right, and sometimes mission-critical decisions do have to get done in the edge. Could you give a few examples of use cases you've seen in the industry?
Well, yeah. Although so this machine tool thing is mission-critical, if you want to call it that. You don't want a $70,000 or $200,000 or $500,000 device destroying itself. So that's mission-critical. But I think it's important to understand that this IoT stuff, it's not all super important, life-saving, or mission-critical, super expensive devices. My favorite example of every IoT is the Withings scale. So it's a scale from a company called Withings, which is now part of Nokia, by the way. Nokia bought it, and I think it's now called Nokia Health or something. Anyway, it's a scale, and you stand on it to tell you how much you weigh, and it will give you your body fat composition. Okay, that's great. And of course, it has some smarts in it. It's an IoT device, so it's got Wi-Fi into it, and it can go back, and there's actually centralized application, so it runs in the cloud somewhere, that tracks, keeps your history, right? Hey, last week you weighed X, this week you weigh X plus 1 pound, maybe you need to go out and do a little walking. Okay, that's all great.
That should have been X minus 4, Bernard. X plus 1.
Well, it depends on the person, of course, and it can help. So you've just outlined exactly what this is and why I think it's interesting, which is there's another capability to this scale, and the overall application is it will shoot out your day's readings on your social media. So you can Twitter or Facebook what your weight is. And most people, when they hear that, they go, why would I want that? Because the reading might be it's X plus 1, not X minus 4. But Penn Jillette, I don't know if you're familiar with him, he's a famous magician. He was a big, bulky guy. He's fat. And his doctor said, if you don't lose weight, if you don't lose 100 pounds, you're going to die. And so what he did was he got this within scale and he hooked it up to all of his social media. So he'd weigh himself, and it would say you lost half a pound over the last week or whatever it was. That would get sent out, and he would get reinforcement. So he built a tribe around his effort.
Weight loss. Wow.
It's not easy to discipline yourself to lose weight, but if you've got all these people going, oh, you're great, that's fantastic news. Anyway, that's an IoT device. Now, I mean, I guess you could say it's life-saving. It saved his life. But most people, I think it's fair to say, don't do that. But that's the kind of thing that an IoT device can be. So it can be anywhere from this smart machine tool that you're protecting hundreds of thousands of dollars of stuff to, hey, everybody, look what I weigh. And anything. I mean, I think that's one of the things that we're in the early days of IoT and we don't grasp this. Everything's going to be smart. And they're going to be magnificent, and they're going to be trivial in terms of applications.
Yeah, and just out of curiosity, the way you're presenting it, it sounds like these computing devices can actually pack a punch and do quite a bit. Do you see edge computing also play a role in analytics at the source of the data potentially, where you have some level of basic analytics done at the edge, and you do more of the core analytics at the hub, if you may? It sounds like that's a pretty good application as well, potentially, for this kind of setup.
Yeah, there's been some examples that are sort of machine learning. So you come up with a predictive analytics, and creating the algorithm, the model, takes a lot of computing power, a lot of data. But once you got the model, all you have to do is stream a much smaller amount of data past it, and it categorizes it or puts it into a rating that it says this is outside the bound of what should be normal. That can be a relatively small computing device. And so you sort of, again, see this kind of bifurcated sort of thing. And so, yeah, edge, I don't know if you'd call it analytics so much as using an analytical technique to apply against data that's located locally. But yeah, that's certainly a use case. And that sort of, just to reinforce what I was saying before, that sort of illustrates IoT is not like a one thing. It's a thousand things, 100,000 things. You've got smart thermostats, you've got a scale, you've got a machine tool, you've got a car, you've got, everything's going to be smart. And
gotcha. Makes a lot of sense. And you're talking about specialized devices, so that makes a lot of sense. So keeping in the norm of cloud versus edge computing a little bit and talking from a human angle, right? An interesting question that actually came up in the forum as well, and I'll take that up right now, is, if you were to give somebody advice who's just getting started on this journey, right? They're deciding, hey, I want to be a cloud guy, I want to be an edge computing guy or a girl, right? What are the skill sets you would say that they would have to pick up on either of these? What are the common things they'd have to learn, and what do you think are the different things that edge computing brings that cloud doesn't require you? Is there sort of a Venn diagram that is there in terms of skill sets you would advise them to have?
Well, I hold the opinion, and this is a little bit controversial, which is that, really the IoT ecosystems of the future are going to be located or provided by cloud providers. So you're going to be using Microsoft Azure or Google Cloud or AWS as your computing environment, your centralized computing environment, and the IoT stuff is going to be sort of, in a way, hung off of that.
Gotcha. A layer on top.
They've created, as like that Azure example I gave with the machine tool, they've created pre-bundled development kits that you use. You place it onto the device. It knows how to communicate. It knows the right protocols. It knows how to marshal all that. So basically, the developer doesn't have to know all the, kind of down at the very lowest level of network protocols and stuff like that. And so that's my belief. In other words, I think it's not nearly as likely that somebody's going to say, well, let me find 8 different open source tools, and I'll tinker them together, and I'll create an IoT connectivity thing and all that. No, you're going to use one of these. And so the first thing I'd say is learn about them and understand them, and then sort of choose which of them, which of the providers you'd like to do that with. And because each of these operates differently. It's not like they're portable. They're kind of pretty unique to the particular provider. So choose the one. And you'll have to know some amount of how to use the cloud piece, because the computing is the sort of the major computing is going to be done there. Are you going to use Azure machines or AWS instances? Or are you going to use Azure functions, or are you going to use Lambda functions? Because IoT and these functions as a service, if you want to call it that, serverless, is kind of like we would say here, peanut butter and chocolate, or peanut butter and jelly. I don't know what the right emphasis would be within India, but in other words, they're very complementary technologies, and so you're going to be using one of those. So learn about the serverless capabilities of the cloud provider, and then really pick up on how that particular IoT package operates and how it works, and what it does, so you can learn about that. So sort of pick your ecosystem and then dive into it.
Gotcha. And one question that many people ask is Azure, AWS, Google, so many choices, right? Is there one that in edge computing specifically, if you were to dive into it, is there an early leader in your mind, or are they all just getting started?
Well, as I said, Google does not currently have an offering, as far as I'm aware. They could, but I'm not aware of one. Both Azure and AWS, I wouldn't say one of them is ahead of the other, and I'd say it's very early days for them. If cloud computing is in the second inning or the second overs, with IoT, it's sort of like the players are maybe getting ready to come out of the changing rooms.
Gotcha.
So it's very early, and there is no clear sort of, yeah, that's the one.
Gotcha. Hey, and by the way, to the specific questions about cloud computing, let me just give a little bit of insight there as well. Bernard answered the question of really, really well. If you know cloud, how do you go about going into edge computing? On cloud, really, you got to pick your provider, cloud provider. You got to decide where you want to be, right? And over time, you can of course get to multiple providers, but getting familiar with their capabilities at a bare minimum, cloud compute storage, is super important. And frankly, you can either just dive in or take a course and do it yourself, right? Just want to make sure I answer the question in its entirety, because that was also part of the question. So let's move on. Hey, so the next question I have for you is, let's jump a little bit into architecture and how people might actually create a device of their own, right? So let's take an application and we want to build an edge computing device that actually does something very relevant, like you mentioned some of these examples, right? At a very high level, what are the pieces that interact? How does one get started on something like this?
Well, typically, you're going to have some sort of a hardware device that's going to put out a signal. And, maybe you're creating that, and if that's the case, then you'll know it intimately. But if not, you'll need to have the specs, what it puts out, what data does it put out, what signals does it put out, and so forth. And then, from a prototyping point of view, you might be using alligator clips to connect to the device output connections or something like that. Although many of them are designed to take that they already have a specialized computing module that can be attached to them. And then what you're doing is loading your program onto that specialized computing module. And, in that case, then, you're going to be using one of these frameworks as either the actual computing framework that you put onto that device, or that you connect from your program on that device to that IoT package. And then it takes care of receiving the data, bundling it into an appropriate packet for the protocol, communicating, knowing how to communicate, so forth. And you'll be setting some parameters, like what's the endpoint that you want to talk to, the API endpoint on the cloud side. And then, you're going to have a program that calls to that API endpoint will get triggered. And that's probably going to be a Lambda or an Azure Functions. Doesn't have to be, but that's very common. And then you're going to be writing that function, and then it's going to go off and do whatever it does. Store the data or run a program or whatever it might be.
By the way, a great question that came on the forum, which I think is very relevant to the question I asked you. So let's say one of the participants wants to get started, wants to try their own edge device that's connected to the cloud, does something interesting. Could they use their personal devices? I have an iPhone here. Can they actually do something with something like that computing power, or do they actually have to get these specialized devices to get started?
I mean, you can prototype something on an iPhone, for sure. It's a computing device, and there's a way to program programs onto it. Yeah, and it's going to, it's going to connect across the cellular network, and so that would sort of qualify as that. And there are many, many, many computing devices that use a cellular network as their connectivity. And the primary example is many people's cars. They communicate over the cellular network. But so that would be quite viable. Another one, if you really want to sort of start easy and small, is Amazon sells a Dash IoT button. I don't have one out. I've got one in my drawer here. If you've seen any of the Dash buttons or heard about them where you press a button and it will order laundry detergent or chocolate or coffee or whatever it might be, it's that form factor. So it's a little oval device, but it's set up to be something that you can do IoT with. So it talks to the IoT service within AWS. You can connect that to Lambda, and it basically sends a signal that says, hey, in fact, it'll send one of three signals: short signal, long signal, or a combination, I think. And you can use that as being kind of the very simple. So it's not a sophisticated device. It's not going to communicate a lot of data, but it will communicate a signal that you can see that you respond to. And that's a pretty easy way to get going. They're pretty inexpensive. And, that will teach you or give you a chance to experiment with I've got a dumb computing device, because there's a little bit of smarts in it, just enough to be able to send out one of three signals and enough to communicate across Wi-Fi to a Wi-Fi thing. And it will communicate to that and send it off. So that's a good way to get started.
Perfect. Really dumb question. I know the answer, but I'm going to ask you anyway because it came up in the forum, right? And I think this is a very valid question, to be honest with you, right? For someone who's getting started from the beginning, right? Obviously, they need this infrastructure. They need to know some of the communication protocol potentially. But in terms of programming languages, coding languages, preferences that actually fit into this cloud/edge computing arena, are there preferred languages out there that coders use today to actually build these frameworks?
Well, as you might expect, Microsoft has C#, and the AWS offering supports Node, Python, Java, and they just announced support for Go, I think. So any of those languages. And Java is kind of the quintessential enterprise language. Python, very widely used dynamic language. So those are good. And Node, of course, is used very widely as well. So any of those languages.
Gotcha. All right.
I just want to emphasize, it's not like you have to be an expert in those languages to kind of get going. I mean, there's a great website called If This Then That, IFTTT, that basically has all kinds of sort of examples and connectivity. And there's another site, it's not coming to me right now, that basically is a place where people share stuff that's really oriented around IoT. I'll try and remember it, and if I can't, I'll see if I can find it and then send it off to you. And maybe put it in show notes or something like that. But anyway, there's resources, and you can start small, and they have code. They say basically cut and paste this code and put it into Lambda. So, with some instructions on how to do it. So you don't have to really know the language. I mean, it's a jumping off point. If you really want to do this, you'll grow your skills, of course. But it's not like you have to know everything before you get started.
Gotcha. Another question that came out of the forum. This one's a little deeper. You got to think a little bit here. The question is, are big cloud service providers going to establish fog servers all over the world? Why would they be motivated to do something like that, where they actually create their farms of these devices out there? Would they want to do that, or is it just going to organically happen based on industrial demand?
Well, that's a good question. And there is I was going to bring it up earlier when we were talking about edge. There is a shift toward that of placing some computing. I don't know that it's so much the cloud providers, because what they've done is they put out what like what AWS calls edge locations, and that's a place that you can connect to that can receive and send. It's an interface point that's not the centralized computing. It's just a place where it can accept stuff, and then it goes onto their network, which is very high throughput and private. It's not going across the internet from that point. But I know that companies I happen to know about Equinix, and they're placing, I think they call them like pods, but they'll place a pod, which is a small data center, located, say, in a location where enterprises may want to connect to them. And it could be, that those would be a place where you could do that kind of fog. I mean, their business case is we're going to build these edge locations, and by the way, they have cross-connect capabilities to those edge locations of the cloud providers. But they're a place where you can locate some computers, and if you're a user, you don't have to go build a little mini data center. They do that, and you just place your servers in there, and they have the connectivity. And it was interesting. I did a podcast a few weeks ago, and there's definitely a business opportunity for somebody to do that, particularly around containers. So, kind of a container hotel. So basically, as a user, you just show up and say, here's my container. It knows how to communicate with these devices. The devices send something. It just goes there instead of all the way back to the cloud provider. This container, it goes into the container. The container then jumps onto the cross connect and then gets to the cloud provider very quickly. So that's a very viable kind of architecture. It's either going to be the cloud providers as they build out, or today companies like Equinix are pursuing that business opportunity.
Gotcha. Final question and sort of the canned question answers that we made, and we'll open up to the forum. Where do you think this is all headed? The edge computing, the early stage that's today, right? If you fast forward 4 or 5 years from now, where do you see this all going, and what's the new future?
There are people who hold the position that says the cloud is dead, it's all edge. And I disagree with that for the reasons I've given. I don't think we're likely to be putting general computing out in decentralized locations because there's a lot of drawbacks to that, which PCs run into all the time. They don't work, something breaks, somebody loads the wrong program, how do you keep it up to date, how do you keep it patched? We will have lots of specialized computing, and it might, over time, come to represent the majority of computing, because, again, every device is going to be smart, and so there's going to be a tremendous amount of computing power out in all these locations. But those will be specialized computing things like the scale or the machine tool or an auto, and nobody will be going to their car and saying, well, I want to run my spreadsheet in it. They're going to be going, I want to be in my car and I want it to respond to traffic or whatever it might be. So we'll have a huge amount of computing out at the edge. It'll just be a multitude of specialized devices. And excuse me, and I believe the generalized computing will be located centrally into one of the cloud providers.
Wonderful. All right, with that thought, let me open it up. I know a lot of questions have already come to the forum, some of which I've already woven into my narrative and questions to Bernard. If there are any questions, this is the time. Please put them in your Q&A section, and we will try to answer them. All right, sounds like we've covered pretty much all the topics that wanted to be covered here. At this point in time, I'll give it back to the host, and thank you all very much for attending. Just to remind everybody, this was done in participation in collaboration with NASSCOM. So thank you very much for attending, and feel free to send us more questions if needed. Happy to address them if needed. We're here for another few seconds, and we'll give it back to the host. Thank you, Bernard. Thank you for your keen insights here.
Well, thank you again for inviting me, Anand. I really enjoyed it.
Wonderful. Thanks, folks. Until next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.